Hey everyone, Professor Adjovan here, and in this video I want to talk to you about solving limits algebraically. Okay, so when we solve limits algebraically, we're going to follow the same strategy for all these types of problems, and there's really four different types of answers that you can get. Fortunately, only one of those four different types of answers is going to require additional work. Okay, so we're going to do all of this under the assumption that the limit at the value that we're evaluating the limit at is equal to the actual function value, right? We know from the last video when we explored what limits are and how to solve them algebraically that the only time a limit is not going to equal the function value at that point is when there's something interesting going on, like a hole or an asymptote or some jump. Okay, every other time it's just continuous and the limit is equal to that function value. So we're going to assume that that's true and work under that assumption and see if anything happens, if anything breaks. Okay. So what we're going to do, if we have to do the limit of this function, the square root of x squared plus 5, as x approaches negative 2, is simply plug in negative 2 and see if we get an answer. Right, so negative 2 squared plus 5 is going to be 9, and the square root of 9 is 3. So because we got an actual number answer, right, nothing happened. We're not dividing by 0. We're not taking the square root of a negative number. This is our final answer. This function must be continuous on negative 2, meaning the limit as x approaches negative 2 of this function is equal to the actual functional value at that point, which is great. That means not much work for us. Well, let's follow that same strategy. Let's just take the number that we're using for the limit and plug it in. Right, if we plug it into this rational function in the numerator, we have 3 squared minus 9, which is going to be 9 minus 9. And in the denominator, 2 times 3 plus 1 is 7. Right, so in the numerator, we have 0 divided by 7, and we know that 0 divided by 7 is 0. Right, so this is kind of the second thing that can happen. We can end up with a 0 in the numerator and a number in the denominator that is not equal to 0. And in this case, it's just 0, right? 0 divided by something that is not 0 is just 0. The third thing that can happen, we're still going to do the same thing, right? We're going to just plug in the number that we're using for the limit into the function, right? We're working under that assumption. But what happens in this problem, right? In the numerator, we have 3 times 1 minus 7. That's going to be negative 4. And in the denominator, we have 1 squared minus 1, or 1 minus 1, which is going to give us this negative 4 divided by 0. So now we have a 0 in the denominator and a number that is not 0 in the numerator. So this, right now, we're going to say it's undefined. And in an upcoming video, we will explore this more to see what's actually going on at this point. But for now, we'll just call this limit undefined. All right, and here's where things get interesting. Well, let's do the same thing. All right, let's plug in 5. Right, so in the numerator, we have 2 times 5 squared, or 50, minus 9 times 5, or 45, minus 5, all over 5 minus 5. And you can probably see what's already happening. We have 50 minus 45 minus 5, or 0, and in the denominator, we have 5 minus 5, or 0. We get this 0 divided by 0. So this tells us something. This tells us this is an indeterminate form. Right, and this is important. If we do this, right, we're solving limits algebraically and we just plug in the number. When we plug in that number, if we get something that is in indeterminate form, that tells us that we can do something extra. We can do something to this function to remove what's causing this 0 over 0. Well, this is a polynomial in the numerator and denominator. So when we see that, and we're seeing this 0 over 0, our first thing that we should try to do is factor, right? We can factor this numerator into x minus 5 and 2x plus 1. Well, if we factor this and we have an x minus 5 in the numerator and denominator, we can go ahead and cancel that. We can remove that out of the problem, and now we have the limit as x approaches 5 of 2x plus 1. So now let's follow our normal strategy of plugging in this 5. And if we plug in the 5, right, it's very simple, and we just get 11. Right, so this is going to be the answer. We've taken what was causing the 0 in the numerator and the denominator out of the problem, and we simplified it down, reevaluated the limit, and got a whole number answer. Right, we removed the discontinuity. What about a problem like this? Right, we're going to do this the same way. We're going to take the number that we're doing the limit at, right, as x approaches 3, and we're still going to plug it in. So we need to see if this is going to be a number answer, if it's going to be indeterminate form, right? We don't want to do any extra work if it's not in indeterminate form. All right, so we plug in 3. And in the numerator, we have the square root of 4 minus 2, which is going to become 2 minus 2. And in the denominator, we have 3 minus 3. So we can already see what's happening. We have 0 over 0, this indeterminate form again. So we can do something. However, this is no longer a polynomial in the numerator and a polynomial in the denominator. We have this radical, right? We have a square root. So when we see that, that is a big hint that the thing that we're going to do is multiply this. We'll go ahead and rewrite it. Multiply this by the conjugate of the radical piece, right? So the radical piece is in the numerator, so we're going to multiply this entire fraction by the conjugate of the numerator. So the conjugate of the numerator, if you forgot what a conjugate is, we're going to take the first piece, the square root of x plus 1, and the second piece, this 2, but instead of having a minus there, we're going to have a plus. All right, now I can't just multiply the top of the fraction by this. We also need to multiply the bottom of the fraction by this. All right, now multiplying conjugates is really nice because we don't need to actually FOIL them out. Right, this is an a minus b times an a plus b. So when we multiply them together, we're going to have the difference of two squares. So I can take my first term, the square root of x plus 1, and just square it to having x plus 1. And then I can take my second term, 2, and I can square that. And then we're going to have a minus, right? Because a minus b times a plus b is equal to a squared minus b squared. All right, now the denominator. Don't go multiplying this out. Leave the non-conjugate piece alone, meaning just rewrite it as the two pieces being multiplied. We have an x minus 3 times the square root of x plus 1 plus 2. All right, we're leaving this alone. And the reason why we're leaving this alone and not multiplying it is so that we can see if something is going to cancel. And what happens in the numerator? Right? X plus 1 minus 4 becomes x minus 3. And look at that. We now have an x minus 3 in both the numerator and the denominator. That x minus 3 that's in both can go ahead and cancel, leaving us with 1 over the square root of x plus 1 plus 2. Right, we've taken out the piece that was causing this 0 over 0, so we can go ahead and reevaluate the limit of this simplified function. Right, so if we plug in 3 for the x, we're going to end up with 1 over the square root of 3 plus 1 is 4. The square root of 4 is 2. Plus 2 is going to be 4. So our final answer would be 1/4. Okay, so to recap really quick, we have a strategy when we solve limits algebraically. Just plug the number in. If it works, great. If we just get a whole number answer, that's fantastic. That is our answer of the limit. If we get 0 in the numerator and a non-zero answer in the denominator, we're going to be 0. If we get a non-zero in the numerator and a 0 in the denominator, we'll call this undefined for the time being. Keep an eye out for an upcoming video to explore that further. And if we end up with 0 over 0, this indeterminate form, if we have polynomials in the numerator and the denominator, we want to try to factor and cancel something out. Or if we end up with an indeterminate form, and we have a square root in there, we want to multiply by the conjugate of the piece that has the square root, whether that's the numerator or the denominator, to cancel out the piece that's causing the 0 over 0, and then reevaluate the limit. Alright, so that's it for solving limits algebraically. If this video helped you out at all, consider giving it a like and consider subscribing to the channel. Thanks for watching, good luck, and we'll see you in the next one.